All right, welcome back. We're going to go ahead and continue on with the Hyperion Project. If you've been following along, like I'm sure you have, right at this point you should have a whole lot of notes showing the framework of the application that we are working on. And you should have a very simple skeletal application put together inside of Microsoft Visual C# 2005 Express. And that's what we're looking at right here. We're picking up right where we left off in the last video, where we put this framework into place. Basically what we did is we started out over here with our default program, and we've only got one little line of code in there. And if you guys recall, what that's doing is calling on our game manager object, and from within it, it is activating the show title screen method, which just is going to echo out some really simple text at the moment. Just as a quick recap, we can go ahead and come over to the game manager, which seems to have fallen off of the screen. There we go, game manager. And here inside of our object game manager, there she is, show title screen. And we're going to say, console, write something out for me. Write out, welcome to Hyperion. And let's go ahead and hit play. Again, this is all just a real quick recap. There's our little program running, and of course it says, welcome to Hyperion. Go ahead and hit enter, Logan. There's the read line. Logan just hit enter. It gave it a line, and of course that returned us back over here to program, and we exited out. End of story. Now, in the last video, we took the time to get all of our objects set up that we needed. So everything's in place, but we went a step further. With all of the classes defined in each class, we went ahead and wrote down all of the actions they're going to need to be able to do. So basically, we have commented each method that we want to have that class have. Okay? Anything you want to add to that, Logan?
No, I think that covers it. Again, just saying that we've noted the functionality. The functionality isn't there yet, but the methods that we need are, or reminders are placed for us to put them in later.
Exactly. So now we're going to start adding on things in this video, and what we're going to do is we're going to focus on getting all of the variables and properties into place. Now, again, I'm assuming that you guys are complete beginners, as we are still dealing with just our Hello World application. So what are these variables and properties? Now, we're going to have a much more detailed discussion of them later on, but right now I need you to have at least a generic idea as to what they are before Logan starts coding them into each of our classes. So let's go ahead and jump over here to the famous whiteboard. Let me grab my pen, and let's start out by writing a very important word. Data. Data. We all deal with data. The computer deals with data. My car stereo deals with data. The TV that I drew on the board the other day dealt with data for you guys. We all deal with data, don't we, Logan?
Even in a more personal sense, we have data like our own memory that allows us to remember where our car keys are at.
That's right. We have memory. The computer has memory.
Most people probably have a form of memory stuck to their fridge or kitchen. That is their grocery list that holds a bunch more information about what they should buy.
Exactly. As a matter of fact, let's do that. Let's go ahead and start with, here's a very simple object. How about we come over here and we draw a person? Gotta love my incredible drawing skills, right? And this person, let's put some variables. A variable is just a place to store some data. So let's give him a couple of variables. One variable could be his phone number. How about that? I don't know about you, Logan, but I know my phone number.
Yep, that's some data that he would know and possibly other people would know.
Okay, so I'm just gonna come over here, and I don't know why I wanted to put it in a cloud. I know, because it's in his mind. That's why. Yes, look at it, it's just coming right out of his head. All right, so he knows his phone number. Now, in that particular variable, in that memory slot in his head, what kind of data do we hold? We hold telephone numbers. And when, of course, we start working with computer applications, computer programs, and we are writing in variables, we have to know what kind of data we're going to store in that. And the same thing goes here. When you ask somebody, what's your telephone number, and they're not going to say, car apple green, that would make absolutely no sense. That's not the right kind of data. They're going to say 555, blah, and that's the data that we were expecting. So,
or even to simplify that, if you ask someone for their phone number and they said blue, that wouldn't make sense and wouldn't work.
You and your simplification. So type. Just throw that in the back of your head. I'm not going to nail on that too heavily right now, but it's another one of those little cute words I'm throwing out there that's going to become critically important in your programming career. All right, so we've got a telephone number. Let's see, what else is something that you can remember? Well, Logan said a lot of people have in their kitchen up on their refrigerator a list of groceries they need to pick up the next time they go to their store. I don't know about you, but I can remember that, right? I'm not always the best at it, but let's just go ahead and add that as another variable. And in this variable, we're going to record things like milk, because it seems like we always have to buy milk. What else? Bread. And I don't know, how about an apple? Because you've got to buy an apple. And again, here we go with a little cloudy because it's something in our brain. And we'll have another one of those little lines coming out to over here. Now, check this out. Again, we have a type of data that's being stored in this variable. The type of data is a list. It is a list of items or a list of objects that I need to pick up from the store. So up here, we're storing a phone number, and I'm just going to write a number. So we're storing a number. Down here, we're storing a list of objects. This becomes very important. And if you recall, we've kind of talked about this a little bit. If I was to go ahead and bring up my layers just real quickly, and if you guys bear with me, if I come over here and hide this and this. Now, we talked about lists a whole lot. Look at that list, right? Remember, the room has a list that contains all of the items in that room. It has another list that contained all of the directional exits that existed in that room. A list. So there is an example from the real world that ties over to our programming world. So you can see it's multiple items. And with this list, can we not easily add things into this list? We can add, also pick up a cucumber. I don't know why I thought of cucumber, but I need that from the grocery store too. And some salt. I need salt. But you see how we can add these things in there? There's nothing worse than you get to the grocery store, you could get a call saying, and you know what, we don't need any milk. I just realized we had some. It's just been sitting on the counter for the last month, and it doesn't really look like liquid anymore. But we don't need any milk. So you can remove things off of the list. But the bottom line is, what are we talking about here? We're talking about data. We're remembering information. And it's just so critical in the real world for us every day to remember information. My car stereo. If I got into my car every day and it could not remember my favorite stations, I would rip that stereo out and throw it out the window, because there is nothing worse than sitting there and hitting seek, 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 or if you're lucky and you have scan and you can scan through. Instead, I can go in there and I can say slot 1 holds this radio station, slot 2 holds that radio station, and I can switch between them until I find a program or song that I like while I'm cruising down the road. The radio has a memory for holding that information. And check it out. What kind of information is it holding? It's holding radio stations. It's not holding apples. No, it's not holding cats. It's holding radio stations. It's a particular type of information. So we truly do deal with this on a daily basis. And that right there is a very good example of data being stored in variables. And we can pull this over into Hyperion right now. If you think about it, we have what? A player, right? So let's draw our player. So here's our player. And we all know that the player is an object, right? Now the player needs to hold some information, but before he holds information, Logan, I better give him some arms. There we go. Okay, no, that wasn't funny, I promise. The player needs to be able to know where he is in X and where he is in Y. Now I'm going to stop drawing them as little clouds. I'm just going to put these in boxes. These are our containers. These containers are variables. All right. And he's also going to need, one more thing. He's going to have an inventory. So let's do this. The inventory is going to contain, I don't know, in our game you might get a key, you might get a gun, and you might get, I'm sure, 100 PDAs. Zach wrote it, so hey. PDAs is where he's hiding information. So this right here, what kind of variable is this? This is our inventory, right? So INVE, INTORY and stuff, right? And now let's make this look a little bit better up here. This is our position X, and this is our position Y variables. And what would realistically be stored inside something like this? Well, let's go ahead and erase this out real quick. Let's make it look. You see what I'm doing, Logan? I'm making it look.
Right, showing the data as well as the name that you use for the variable.
Showing it actually in use. So with that, let's say that it was holding 1, 2. So now we know column, comma, row. So we can quickly look at the old grid. Remember 1, 2. We can do one of these numbers. We can just come back down here, and he's in 0, 1. He's in 1, 2, 0, 1, 2. And here we go, clicking on all sorts of things. I didn't mean to do that. So he's down here in this location, and we know that because of what is stored in his variable. That's variables. And variables play such a huge role in software development. I mean, every single application that you're using on your computer right now or forever has got variables. That's just how it goes. We need to store information. Now, it gets a little bit more interesting. Let's go back to the whole telephone number thing. You don't always want to be able to have anything, any object, or any piece of code within your program be able to access a variable. Let's go back to real world. We have got this really, really, really cute girl. And there's her long hair, right? And she has a telephone number. So we have another, and she's going to be called Jane. Okay, so there's Jane. Now we have some guy over here, right, and who's missing a leg. And this guy, of course, he's like, hey, Jane looks pretty good. And Jane has a telephone number. So here we can go real quick and draw one of those little lines in a little cloudy area. And we'll just say tel num. That's our telephone number. Do you really want Bob to be able to gain direct access to the telephone number? No, she's not going to want that. Do you want Bob to be able to walk into a club and just look around and go, all right, and then just go home because he now has all of the telephone numbers in there? No. I mean, think about it. Don't we have the ability to make our telephone numbers unlisted if we don't want people to locate us? Now, for someone to get our telephone number, they need to come and talk to us to get that number. What we're doing is we're now introducing something to go a step beyond variables. We're now going to introduce a property. Okay? The telephone number is going to be both a variable and it's also going to be a property. When Bob approaches Jane and says, Jane, can I have your telephone number? Even though he's using the word telephone number, he's not accessing the telephone number actual variable in her head, is he, Logan?
No, you can't. We don't have telepathy.
That's right.
Not most people. Anyway.
Not most people, precisely. Shh, don't tell them about the things I can do when we're not recording videos. So he needs to be able to ask her, and then she can decide. And so this is pretty nifty because now we need to, instead of just directly accessing the true telephone number, we need to be able to ask her, can I get your telephone number? And she needs to say yay or nay, and here it is. And the way we're going to do that is we're going to, and for those of you that know about programming properties and variables, just have faith in the way I'm explaining this. There is a method to the madness, as Zach loves to say. Here's our box that is going to hold our telephone number. This is her telephone number in there, okay? Now what I'm going to do is I'm going to put kind of what I'm going to call a wrapper around it. This is all just an analogy, okay, guys? So it's just kind of wrapping around it. So the telephone number is inside this. Though you will see when we start coding, that's not exactly what's happening. This is just a visual way of seeing it. So there's telephone number. And out here, this wrapper, as a matter of fact, Logan, to make this a little bit easier to see, I'm going to make that a little L. And out here, we're going to call the wrapper with a capital T here. So small tel num and then a big tel num. Now, this right here is a property. And the property we can access directly because we're setting that up so that Jane can interface with other people and other people can ask her what her telephone number is, and we're going through this property first where some decisions can be made if we wanted to. I mean, in the most simplistic form, we could simply say, ask for this, This can say, all right, let's grab our information that's in that box, and let's turn around with that information and put it back here so that it can be sent back out. So I want it. Well, let's grab it from in here. Let's send it back over so that it is now on its way back out. Does that make sense?
Right. The telephone number property is more like the vocal asking for a telephone number.
Exactly.
So you ask for that, and then that telephone number property can reach into the variable, can grab the data out of that variable, and give it back to whoever was asking.
Right.
So to whoever was asking gets a verbal response of the telephone number.
Precisely.
But it's the person who owns that telephone number in their head. They can look into their memory, and they can decide or get their telephone number and tell it to someone. So vocally speak it back at them.
Exactly. And that's why I put this nice little cloud around it, because we've now cushioned or we've protected, we've cushioned it away from anyone else that we may not want to get it, because now I can come in here and I can put a question mark here. This question mark, we can do all sorts of stuff in here. So if, Logan, if you happen to walk up to Jane and say, Jane, can I have your number? Then Jane can say, let's see, well, he's a cute-looking guy, and I'm single at the moment. Yeah, let's give him the number. The number is, and then she gives it back from you. And she accessed her variable and got that to her private variable, because it's private. I don't want it public for everybody. She accessed it, and she handed it back through public channels, through her telephone number property. Is that pretty clear, Logan?
Yeah, perfectly.
I mean, to some of you guys, it may be like, oh, that sounds clear, but it's kind of confusing.
Yeah, perfectly to me.
Yeah, perfectly to Logan, but it may seem a little bit confusing. I promise you it's going to get more and more clear, and we're going to come back and we're going to visit these things. But the bottom line is we actually will have a Jane.TellNum property that we can get information out of. And this is going to become really important, because properties, we don't want everybody to be able to access everybody else's variables. So we can put this up as a way of safeguarding and making decisions before we pass data out. And the bottom line is, if we gave direct access, if we go back over here, all right, so I'm back over here with Bob, if you're trying to find where my mouse is at. With Bob, if we gave him direct access to her telephone number, oh yeah, this could be a mess. Now he could brainwash her. He could change her phone number, because he's got direct access. She can go out. This is how it needs to be in the real world. She can have somebody that got her telephone number, but through the proper channels, and then later on he turned out to be, well, not the nicest person in the world, so she changed her number. It's now a different number. He has to approach her again through her property to get that telephone number. He does not need direct access, and he sure doesn't need the ability to go in there and change the number himself. Oh, that would just be a messed up situation. So this is kind of a real-world analogy of how variables work and then properties work. And properties are used to get at these private variables that are contained within the object. So let's see. I got another one. How about another example that starts introducing this public and private thing? Because they're going to see public and private so much it's going to just make them nauseated. Actually, not really, but they're going to see it a lot. So public and private. Let me see. What do I want to do? I can come over here and maybe push this down just a little bit, just like that. Ah, beautiful. How about, I'll come over here. That's right, public. So I'm going to drop some more words. And I'm going to write private. Now, we've kind of seen that. With Jane, her telephone number, the actual variable, that's private. That's private to her. That's the bottom line. To get access to it, we need to be able to ask her her telephone number, and we can ask her her tel number right here through the TellNum property. That needs to be public. If that was private to her as well, I could then walk up to her and say, TellNum, meaning give me your telephone number, and she would go, huh? Because it's private to her. I can't get to it. So she's just going to pretend she has no clue what I'm asking. And internally, she can ask herself what her own telephone number is, access that information, and remind herself, yeah, oh yeah, that's my number. Okay, cool. And that's all internal to her. But in this case, her telephone number is private. The access point, the property to that telephone number, is public. I have a really cool idea, Logan. Let's see if I can pull this off. Let's draw a new object. Let's get away from poor Jane for a little while. Let's draw a big old box. Like such, yeah, with my great drawing skills. And this box, let's call it a security, because we're dealing with public and private now. So I want them to start thinking security. So this box is going to be a security firm. Security firm. And the security firm has, let's see, what kind of security firm? This is one of those really cool Swiss-type security firms that we got to actually fly over there and deal with firsthand. Top-notch stuff. It has a whole bunch of security boxes. Yeah, that'll work for me. So here is a security box in which I can put very important stuff. So we'll call this our security box. Now, let's put me. I am standing outside the security firm, and I'm happy because I'm able to go to a security firm. And I can walk up to it, and there's a window access slot into it. Now, I need to put stuff into my security box. Or, hang on, does it belong to me? No, it doesn't belong to me. I can access it because I was nice enough to pay a large sum of money to the security firm, and so they were nice enough to give me a place where I can store valuable stuff. But this particular firm, it is not going to allow me to just walk right in, right up to my box and open it up. I mean, I know there are some types of security deposit box out there where you can access them directly, physically yourself. That's what they get for making those public. This is private, though. This I don't want to be able to access directly. So I'm going to make this right here. It's private to the security firm. Okay. So this is a variable. The security box is a variable. Stuff goes in there. And it's a private variable that only the security firm can access. Nobody outside, including me, can access it. If you think about it, this is just like Jane and her telephone number. So we got me, and we've got Logan, who better not get in my security box, because I have no idea what's in there, but it's important. So I need to be able to access that. So there is a security manager. Let's go ahead and give him some arms so he doesn't look weird, and now, don't let this be misleading. I got to throw this right up front. Security manager is not an object in this case. In this case, we're just talking about variables, and we're talking about properties. So what is our security manager? He's a property. Why is he a property? Because I'm setting him up in such a way that I can interface with him. I can say, security manager, I need you to put this into my security box. The security manager is what? He's public. Anybody can walk up to the security manager and talk to him. Now, the security manager goes, let's see. Yep, that's Buzz, and Buzz is allowed to access his box, this variable back here. So let's go back here and put X into his security box. So through the security manager property, I was able to deposit something into the security firm's private security box. Okay. Now I can also say, well, I'm talking to you again, Mr. Security Manager. I need you to get something out of my box for me. I need you to get me what is currently in there. Because it's not like I'm putting a lot of things in there, because this isn't a list, but it could be. But in this case, it's just holding one thing. So get me X. So the security manager says, okay, I have verified that you are allowed to have that. So here you go, and I am going to give this back to you. Fantastic. Thank you very much. I've got my information, and I leave. Check it out. It's almost like it's my security box, but it's not my security box. It's the security firm's object. Again, just dropping words. This is an object, if I can spell. And this is a variable. And this over here is our property. I know I'm going on forever about this, but I want you to have just a decent idea as we start to code this stuff. So check it out. I've gone in, I've talked to the property went to the variable, got the information out, and gave it back to me. And remember, public, private, dropping those keywords again. The security box variable is private because only the security firm needs to handle it. Well, here's what's really cool, because now inside this object, I've got some security text. Ooh. So here's some security techs. So he's Tech 1. And this guy over here, he's Tech 2. They like their names. I hope you guys do too. Tech 1 and Tech 2, they are allowed access into my security box. As scary as that may sound, they are trustworthy. How do we know? Because when that security firm created itself and put all of the people inside of it that's going to be doing all the work and all, they did background security checks. They made sure that everybody was clean and trustworthy and weren't going to screw around with the stuff that's being stuck in those variables, because that could cause trouble. We don't want trouble. So they're clean, they're good. And the techs are there in case, well, security boxes, they need to be cleaned out from time to time for whatever reason. Cleaned out as in not removing your information, but wiping the box out with a rag.
The lock on the box needs to be oiled or some other maintenance style
You got it.
task.
So that's what the security techs are there for. So they can access it directly because they are inside the security firm. So keep that in mind. So that's kind of a big picture with an analogy of wrapping this up.
Another reason it's still secure to have the technicians access your box is the technicians themselves are private.
That's right.
You can't walk up to a technician. No one can walk up to a technician.
I love it, Logan.
So even if the technicians weren't so trustworthy, no one can get to them. They don't have the option of giving your information to anywhere outside of the security firm. Only the public security manager is able to do that.
Great job. I love it. I didn't even think about adding that in. That's what we get for doing some of this stuff on the fly. But he is absolutely right. Do we see where these security techs can walk up to the window? No, they cannot. Only the security manager has the right to walk up there and interface with me outside the security firm. These techs, they live, breathe, eat inside the security firm. That's where they live. They don't even go home. They stay there. And they're robots. Yes, there you go. That solves everything. So that's it. In a nutshell, to wrap everything up before we jump over into our code, the two key things I wanted you to get out of this whiteboard lesson are, and let's go ahead and jump back to the top, variables and data. We know that we're going to have to store information. That's the bottom line. We have to store it in the real world. The items we interface with in the real world has to store information. Our computer programs are going to have to store information in the computer's memory. This storage is called variables. That's where we store it. Now, the type of information that's stored in the variable will change. We've already seen right here with telephone numbers and lists, two different things. And then over here, we've got a position X and a position Y. Oh, well, while we're back here, check this out. I can now apply that public and private example. In this particular case, I would want to make his position X and Y public. Why would it be public? Because anybody can see where he's at. I know where Logan's position X and Y is right now. He's sitting right by me. I don't know his telephone number unless I ask him, but I know where he's at. He's sitting right there. Now his inventory, you know, to be honest with you, I'd want that private. I wouldn't want to know what's in Logan's wallet right now. I wouldn't want him to know what's in mine. Or let's say that we're talking about Jane and she's got her purse. And a purse is, again, it's a container, so it's a variable. And inside it, she has a bunch of stuff that goes in there, and she's not going to want me to know.
A key, a gun, and a PDA.
Yeah, a key, a gun, and a PDA. If that's in her purse, she's probably some sort of operative, and she's not going to want people to know that, because then she'll have to use her gun to take care of that person, and then her key to escape. So we private. Now, does it have to be private? No, it does not. It really does come down to when you're designing an object-oriented program, you really got to think about, do I really want to expose this information to everybody? Do I want everybody to be able to access it? Sometimes yes, and sometimes no. Generally, you're almost never, actually, you pretty much never want anybody to just access variables directly in almost all cases. So you're always going to have a property that they can interface with that will then work internally within its own self to get the information out of the variable and put information into the variable. So properties have the ability to get and set information. But within the object itself, you can start working with its own variables because it can see both its public and private variables. All good?
Yeah, and again, just to drive home the point of saying that you would never really want anyone direct access to the data, you could make a property very simple such that it never made any real decision. For example, you could have a property of any person being the ability to ask them if they are okay. You're never going to decide whether or not to say whether or not you're okay. You might think about your well-being and am I okay right now, and answer yes or no. But it's going to be very simple. You will always give an answer. Someone can always get your "Are you okay?" But you would still put it as a property so that they have to ask you instead of being able to go into your mind and get or change that.
Exactly.
And again, with the something like a phone number, you wouldn't want the data to be public, even if you were a sales representative. You would always want to have people have to ask, because if the data could be accessed by anyone, then someone could go up to that sales representative and change their phone number in their head without them knowing.
Right.
So they'd suddenly be able to try to get their own phone number and they couldn't anymore.
Right. Big problem.
It's to nothing else. A property will let that object know that it's being accessed. That's another key point of it. If it's just the data can be changed without anybody knowing about it.
And this stuff is going to make a lot more sense as we get deeper and deeper into it. But again, I just needed you to know what variables and properties are. So back to the final thing I was saying as I was wrapping it up, that we know that position X and position Y, that as I just said a second ago, are public. Look at this. They're holding a particular type of data. There goes that keyword type again. They're holding integers. That is one of many different types available when coding, because obviously we're going to need to tell the computer we need to store this kind of information so the computer knows how much memory to set aside for that information. Because otherwise, I mean, what if you just said, give me all your memory? Well, now you've got a problem and the computer can't function no more. So in this case, we're going to be storing integers, because you can never be at position X 3.8. That doesn't make sense. This is a straight out grid, so it's always going to be a whole number. So that's storing a type integer. Well, our inventory, our private inventory down here, we've noted that it is a list. It is multiple objects. So we're actually storing objects in here. And guess what object we're actually storing in here? Item. Remember that? We talked about all of the different type. As a matter of fact, if I come back over here, talked about all of the different objects. So we put out the class for that object. Here we are at items, and inside Hyperion, there it is. So we've got multiples of these. And remember, check it out, just as a quick reminder. Do you see the word static in there? No. Remember I said a static class, only one of. If we're not using static, we can have multiples of. We can create multiple objects from this class. And so in this case, back over here in my drawing, that's what we're taking a peek at. I have multiple items being stored in there. So variables, place to hold information, properties, a way to get and set those variables, and we can have other computations taking place inside to determine, do we want to do any manipulation with the information we get or set? And the property doesn't even have to talk to a variable. That's cool too. We could have a property that's going to take a look at other stuff and come up with some sort of piece of information to hand back to you. And we'll actually see that when we talk about inventory weight coming up. So Logan, I think that is a pretty good beginner introduction to variables and properties. You happy with it?
Yep, I agree.
Now for the fun part. Let us code. So if you want to go ahead and jump on over to Visual C# 2005 Express. Back within our IDE. Ooh, here I am dropping these words all the time. So now what we need to do is we need to start putting our variables and properties into place. And for almost every variable, we're going to have a property so that we're not doing direct access to the variable. We have to go through the property. So with that, Logan, let's go ahead and throw a few in and we can start talking about these.
Okay. We're going to pick on the room class first. So let me get room loaded up. And of course, above the public methods, we'll drop down a few spaces to give ourselves some room. And we're going to create the first variable that's going to be stored within our room class.
Okay.
This variable is going to be a private variable.
Oh, how cool is that? It matches the notes back over there.
And this variable is going to be the title. It's going to be the title of the room. Title is going to be of type string because it needs to hold text.
Okay.
I guess a really simple overview would be the string type can hold alphanumeric characters.
Yep.
One or more.
So now we're going to tell it that what it holds is a string.
And then the only thing left to give is the name of this variable. And that variable's name is going to be title. So that's the name that we use to get the title out of this object.
Now as a quick reminder, with the Hyperion Project, our little Hello World app here, This is what we're expecting monkey see, monkey do. So if you're looking at this, raising an eyebrow, just slightly confused, please just follow along. This stuff, we're going to break it down hardcore later on. Right now we want to build this full functioning game. So right here, this line is defining a variable. Logan, if I can grab the mouse real quick.
Sure.
This line is defining a variable, a place in memory that we can store information in, and so that we can get to that location and retrieve information and put information there, we give ourselves just a name, a descriptive name of what that place is going to be called, title. We tell it what kind of information is going to be held in there. And as Logan just said, a string is alphanumeric characters. It's just text that we're going to be putting in there. And check this out. We started out the whole thing by saying that this variable is going to be private, meaning that only class room, so the room object, will have access to the title. Okay? Nobody else. So in other words, back over here in text utils, we cannot gain access to the room's title. Now, if we put a property in place, which maybe we want to go ahead and do that real quick.
Right, that's actually the next thing I was going to put in.
If we put a property in place, then perhaps we could ask, well, we actually could ask the room what is its title, and it could give that to us. So let's go ahead and throw a property down. So they've seen both a variable and a property.
All right, now this property is going to be public so that other things outside the room can access it. It is going to be of type string because that's what we want to return.
Kind of information.
The public information is going to be the same type. It's going to be text. And for the name, I'm going to use the same word but with a capital letter. Start it with a capital letter.
As a quick reminder, the language C# is case sensitive.
Right, that's a good thing to keep in mind, that this title is different than this one. We could have, if we had made both of these just simple variables, we could store two different things. We could have one string of text inside of the lowercase title and a different string of text inside the uppercase title.
That's right. So just keep that in mind. Because he's using this capital T at the beginning of title, this is just a convention that we're following so that it's real easy to see what property goes hand in hand with what variable. Okay?
Right. I mean, we could go so far as to actually change the letters in this. We could write this out as our public title.
Exactly.
The only problem with doing that is that's redundant outside because you can just use the IDE to look in or to analyze a variable and it'll tell you, oh, this is public. So
right.
We don't have to write that ourselves. It is just nice for an aesthetic purpose to have the capital letter on anything public.
Right.
Just as a kind of formality. But since we're going to define this as a property instead of as a simple variable, I'm not going to terminate it yet. Instead, I'm going to drop down to the next line and begin a new block of code.
Okay.
Inside of this block of, I guess technically you could call it code, I'm going to add yet another block. Even though I'm going to put this block on one line, I'm going to use the keyword get, then open and closing curly braces. Inside of these braces, I'm going to put the code that should run whenever we are asked to get the value of this property. What is this property going to do?
Okay.
Well, it's going to look at the title variable and return whatever's in it. So we will return title. So that way it's like something is actually happening. If we ask title what its value is, it's going to look into the title variable and return that. Okay. So very simple. No real decisions made. Again, this is like a simple form of property. The only upshot here is that you can acknowledge that title is being accessed, even though all it does is simply reach into the title variable and give the data back. Now, on a room, when we're setting up our level, we need to be able to set the value as well as return it. When our level is building itself inside of the level initialize, we need to say, all right, we've made a new room, set its title. So this property needs to have a set method as well.
Okay.
Basically, this property has to be both readable and writable. So inside of set, what do we need to do? Well, we need to remember, because when we're inside of set, we're going to be given a value of the type of property that we are, and that's accessible under the keyword value. We need to take that value and store it somewhere, because title itself doesn't store anything. It just provides a little bit of functionality. However, our title variable can store data. So we need to take that data and put it into title. So we take the title variable and set it to whatever our incoming value is.
Now notice something. For those of you that are completely new to working with a programming language, check this out. In our IDE right here, inside of Visual C# 2005 Express Edition, you'll notice a lot of these words lighting up blue. As a matter of fact, you see all sorts of different colored words. Let's just focus on the blue for a moment. These are our key words. These are built into the language here, okay? So it's not like Logan is just randomly making up the word get and we're assuming that the computer is going to blah, blah, blah. Get is something, it's functionality built into our language here, okay?
Right, into the, in this case, into a property, where this is how, when C# goes to put this all together and assemble it, it's going to see that we had started a block below it and put a get and set in, so it's going to know that this is a property.
Exactly.
And that within get, a certain type of code should exist, and within set, a certain type of code should exist. I would imagine that, value is the incoming value, but again, just that things are expected to work in a certain way.
Right.
And you can't just type get and set outside of the
correct.
The property itself. Things have a certain context they have to operate under.
So I know right now everyone is just following along with us, but we're just trying to give you just a teeny foundation. It's not all magic. I mean, there is a format that is being followed here. Now, before we move on, since we are now adding our blocking braces for the very first time, I would like everyone to turn their attention to the keyboard. So actually look at your keyboard. When you are using those curly braces, look over on the right-hand side of your keyboard, not all the way over to your numpad, but over by the Enter key, okay, right above the Enter key. And this isn't on every single keyboard in the world, but it is on most, at least most American Standard keyboards. You will find right next to the letter P, to the right of it, that's going to be our key that's going to have our curly brace, our opening curly brace, and then the next key next to the right of it is our closing curly brace. And what I'd like to do real fast, Logan, if you don't mind, is just so everybody sees this, go ahead and come back over here to Photoshop real quick, because sometimes it's kind of hard, right, to see what the curly brace looks like after this is the video is compressed in resolution and all. So what I'm going to do is just come in here, add a real quick layer, and let's go ahead and just flood it, and then another real quick one, so now I can start erasing stuff. And curly brace, this is our curly brace. So an open curly brace, we put some code in here, and we put our closing curly brace. What we have just done is created a block of code, okay, and this is going to become very important as we continue working further and further into learning how to master this language. We're going to find that when we start doing things like, let's say, a conditional test, and then if the conditional test is true, we need to perform this block of code. Otherwise, perform this block of code. So you're going to start seeing these open and closing curly braces used all over the place. In fact, you've already seen it. Just in setting up the classes alone, if I was to jump back over here into the IDE, you'll notice that we've got an open curly brace. Heck, we can go all the way back here to the namespace, where it has an open curly brace, and all the way down here at the bottom, as you can see, it's nice enough, the IDE is, to go ahead and highlight my closing curly brace, and it is blocking all of this code in it. And now within that, we have sub-blocks of code. We have the class. We have an opening block for it, and look, follow down, check it out, it's highlighting its closing curly brace. And so it's blocking all of that code in. And then to go down further, here, Logan just came in and created this section right here, our property, that is blocking this code. And this basically denotes that this code belongs to this guy right here. As all of this code, and if I was to keep going down, belongs to this, and this, which basically means everything, belongs to the namespace. So I hope that kind of helps, you know, as you see these curly braces get introduced, you now know where it is on your keyboard, and you know what it actually looks like, as I have drawn a bit. It is not an opening or closing parentheses. It is not the opening and closing square brackets. It is the curly braces. Yes. And finally, I'll add one more thing, and this is something we're going to talk about in detail a little bit later. You're going to notice that Logan is using semicolons, and he's going to use these a lot. These are terminators. Okay? This language it supports white space, and we can use that to format things, which means a line's not over until it hits a terminator, and that terminates that line that we're typing out. And that line doesn't have to exist all on one physical line. It could actually be broke up over multiple lines to make readability back over here in the IDE a lot easier for us. We'll talk more about that in detail later. I just wanted to point out that you're going to start seeing these terminators pop up all over the place, and that's what it is. It is terminating the line. Now, there are places where you're not going to see a terminator because we're not terminating this right here. This right here is saying we are making a property, and here's everything that belongs to the property. Now, inside the property, we had lines of code that ended up getting terminated. And this is kind of a special case because of, we've got the closing braces out here. It'll start to make a little bit more sense later as we get deeper, but I did want to throw out that you're going to see terminators all over the place. And as you guys are following along, if you're not paying very particular attention to two things, the casing that you're using on your letters, capital and lowercase, or terminators. That is the number one area that the beginners, believe it or not, the professionals too, get in trouble and introduce bugs into their application. They got the casing wrong or they forgot a terminator somewhere. Please keep that in mind. Okay, so with that very quick little side lecture out of the way, let's continue, Logan.
Okay. Well, with that, with our private title and our public property title, that wraps up title for this room.
And if you don't mind, just as an example now, let's pick any place, it doesn't matter where, since any place, I want you to go and let's since we're using namespace, right, let's go all the way back to program.
All right, so if we go...
So in program, if we hit enter, we can now actually... no, this
because
one,
of, yeah, because
room
it happens to be
room is a special case. So the example I wanted to give you is not quite going to work because, see, remember, all of our classes, except for just a couple, are static. Room and items are not static. We can have multiples. So we actually have to create a room before we can address it. In all other cases, we can address it immediately. So this little example I was about to show you, I'll show you in a minute.
So we'll postpone it for just a minute.
Yeah. You saw where I was going, though.
Yeah, I did. All right, so back to room now. Now, title isn't the only thing that we're concerned with. There's other types, other pieces of information, other data that goes along with the room. And something very similar to title, but in fact different, is the description. This is the full block of text which will describe in roughly a paragraph what is in this room.
Exactly.
And as far as we're concerned, we're going to handle this in the same manner as we did the title. We're going to have a private string variable that can hold the description data, and then we're going to have a public string property that will access that data from outside this class.
But this time around, go ahead and show them something cool that the IDE can do.
Right. You saw how there was actually a little bit of stuff we had to type out. We had to make the private variable the public property, go into the public property, and write out a block for get and a block for set, as well as write some code inside of that.
Mm-hmm.
There's a template within Visual Studio that will create this for you and allow you to type only the relevant pieces of the property and its related, the variable and its related property.
Okay.
And to access that template, you can begin to type out the word property, and you'll see prof actually highlighted in things that you can access. As a matter of fact, they're calling it a code snippet for creating the property. And if you want it to flesh that out, you can press tab twice. So tab, tab.
Ooh, look at that. It threw a whole bunch of stuff in there.
So it lays the property down, and it doesn't just leave off there. It actually has the key areas, the type, the variable name, and the property name all highlighted. And you can move through these by pressing the tab key. So I'm on the type. I'll hit tab once. Now I'm on the private variable name. I'll hit tab one more time, and I'm on the public property name. And these are the three things that differ between this block. Everything else is the same code. Again, it's just accessing the variable. So to finish this out, if this is indeed going to be our description, it needs to be of type string. So we'll type string for the type. I'll press tab to move on to, or I'll tab to move out of the list, and then tab again to move on to the variable name. And this will be lowercase description. So description. See, there's an R in there somewhere. There we go. That's better. And then I'll press tab one more time, and you'll notice now we're on the public name, and look down here, these are starting to change.
Yeah, actually, you'll notice this is really important. I'm pointing. I don't want to take the mouse around. Actually, I can. without clicking to highlight anything. You'll notice, follow my mouse. Look at this, string, it automatically updated that.
Oh yeah, I didn't even notice that. That got updated as well.
It updated that for us, and down here it updated this for us to say description because we're returning the description, okay? So I just wanted to throw that out there real quick.
So now we're on the last piece, the name of the public variable, and this will be description with a capital D. So
again, everybody outside of this object can access the description variable with the lowercase d through the public property description with the uppercase d.
So now that I've got everything put together for this property, I can press enter, and that'll take me out of the creation phase for this property. And so now I have my, I guess you could call it the variable / property pair. I've got the private variable to hold the description and the public property to access it. So looking at this, it's identical to the one we had typed out by hand for title, just with this one being for description.
Very nice, very nice.
So, alright, that takes care of description. Now we can move on to the next property for a room, which is the exits held within that room.
All right, this is going to be a little interesting because let me remind everyone, what did that look like? As a matter of fact, if I can steal this away, I know everybody's going, oh, not again. What do the descriptions look like? Oh, I need my pen for this because I can't see my mouse. So over here, we can hide, we can hide, we can hide, we can hide. And inside our room, once again, we were able to keep our list of items and list of directions, right? Right. So we're in a room. That means we now need a variable that holds a list. And I already gave an example of this. A person in their head having a variable holding a list of grocery items that they're going to buy. So we need two lists to exist inside this room. One for holding our items and one for holding our directions that we can go. So, all right, look, if you want to jump back over, I just wanted to remind everyone, we've actually drawn this out.
So again, starting on the private variable, I'm actually going to go back to typing out the variable myself, because you'll see in just a minute I'm actually going to rearrange the variables and properties just a little bit differently once I'm done putting them all in. But anyway, now we're on to the first list we're going to store in this room is the exits list. What directions can you leave this room from? So we'll begin this as a private list, and we're going to say that this list will contain strings. We're going to hold directions as strings in the game, and the name of this variable is exits. And I'm going to make this variable name plural to hint at the fact that there can be multiple things inside of exits, because exits is a list, which means multiple of this type, so multiple strings can go inside of exits. Now, here's something else that's a little bit interesting. Thus far, we've always created a public property to go along with each of our variables. In this case, I'm going to leave exits completely private and not give a property to access it.
Okay.
Later, when we get onto the methods, you'll see there's a special way that we're going to handle exits.
Sounds good.
So, no property for exits. We're going to move on to the next variable, which is also a list. This will be the items list for the room. So we'll begin a private list, this time of type item. And notice here where item was a built-in type, string was a built-in type, item is our own type. As a matter of fact, if I hold the mouse over it, you can see it's class Hyperion.item. So this is a type that we have defined. This is actually why we went and created all these classes without finishing them, is so that when we get into other classes that have to know about each other, we'll have those types so we can fill them in the framework. So that's actually a really good methodology to go and framework everything in as a skeleton, because that way we have our item type even though there's not much in it right now. But again, the reason we're making a list of items is this will hold all of the items that exist within the room. So I'll simply call this items, just like I did with exits. Now,
that's it, I believe.
Except for items is going to be publicly accessible, because there's not. We'll get into the special case for exits, but with items, we do want to be able to, from outside of the room, look through the things that are inside the room. And since I've already described it, as a matter of fact here, I'll do this. I'm going to copy one of my existing properties just to save a little bit of time in typing and change it over. So let me copy my type over string, let me copy my name over the title, though I am going to change this to capital items.
Because it's a property.
And then copy the variable name over the variable name within items. So there we go. Now that has all of the variables and properties in place, but I'm not 100% happy with the way that this looks just visually. We have private variables mixed in with public properties, and if you had a lot of these, or even right now, the screen is mostly filled with all of the properties. So if we wanted to hone in on one specifically, it could get a little bit confusing because we go variable, property, variable, back and forth. So what I'm going to do is I'm going to define a region for all of our properties. And then we'll end that region. And region. And the other reason I'm going to do this is because where you have a variable that happily exists on one line, the way we're structuring the properties, they take up 5 lines. So it actually takes up a significant portion of the space on the screen just to have these properties lying around. So I'm going to take each of...
So he highlighted it and hit Control X.
and Control V, drop it into the property section, and I'm going to do this for each of the properties.
Real slow, so everybody can follow along.
All right, so that was the description property. I'm going to jump in just above items, drop down the line, hit paste. So there's our description, and it is still spelled wrong. It was, give me just a moment. Let me correct this. I didn't catch it at first, but it was just kind of bugging me, and my eye would twitch whenever I'd look over it.
Gotcha.
So there. Okay, again, just correcting the spelling for description. And the last property we have is the title. So select all of title, cut it, move down to the properties section, jump in before description, hit paste.
And again, if you're having a hard time following what Logan's doing, all he did was he just cut each of the properties, okay, and moved them all within this new region that he's defined, which go ahead and show them the power of the region.
Well, let me finish neatening things up, and then I'll show you what's so cool about using a region for this. Is now we can take our variables, align them all neatly, so we have simple single value variables like title and description. Then we have our lists, again, all of this being private. And then we have this property section, which gets a little long-winded if you're just reading through it. So we can take our region now, collapse the whole region to a convenient little box.
Yep.
So now, just glancing at this class, we know we're going to be dealing with things like title, description, exits, and items. And if we want to know what the external properties look like, we can always expand and look into it, or just assume that that's fine, I'm actually not even interested in properties, let me move on to the code.
Very nice.
So with that, that has our variables and properties taken care of for the room class.
Okay.
Now we can move on to the level class. So let me jump over here. We have level, and we have our notes for what methods, and I'm going to just drop down a line or two.
Before you put anything in there, because this might look a little weird to them, I'd like to just jump back over here once again into our whiteboard and remind everybody that we drew this picture level, right? So here's the object level. And what did the object level hold? Well, if you look at this, technically it's only holding one thing. See this blue box? That's the only thing inside it. Now there's things inside the blue box and then things inside the red boxes, but the level itself has one thing inside of it. It's a rooms grid, and it is the grid that's going to hold all of the rooms. So the variable that we're about to create is going to be our rooms grid.
Right, that's what we're going to focus on for a minute, is creating I guess you could call it the data type for that rooms grid within our level. So let me jump back over to Visual Studio, and we're inside of level, so just for visual reference, that's where we jump to. Is that level you saw in the diagram? This is where we're at now. We're at the level class. Now we're inside the level class, and we need to create a rooms grid. So since we know this is going to be a variable, and we're in a static class, it's going to have to be defined as static. We can type that part out. We have a private variable that is static, and we're going to call or rather, before we get into the title, now we need to define the type that this is.
Now you'll notice there is something new from what Logan was typing a minute ago when we were dealing with the room. He's now typed the word static. This is because we're working with a class that is static. Since the class is static, all these variables are going to have to be static as well as properties. Okay?
All right, that's a simple description until we get into static more in depth later. But for now, we've got our private static, because it goes with the static class, variable. Now, this is going to be the rooms grid. So what type is this going to be? This might be a little tricky, but just follow along for a minute. We're going to say that this is of type room. Type that out correctly. Room being our own room class that we defined earlier. Now, instead of being just one room, this needs to be a grid of rooms, or an array of rooms. So I'm going to do an open square bracket. Not only is it going to be an array, it's going to be a two-dimensional array. That's what facilitates our grid. So I'm going to place a comma and then a closing square bracket. And that's going to basically saying that this is a two-dimensional array of type room.
And the comma, remember when we were back over in Photoshop and we were whiteboarding everything out and we said a room with a position of 2, 3, there's that one comma, separating two numbers, and this indicates a two-dimensional array.
Okay, so with that out of the way, the only thing left is to give the name of this variable, which is going to be called rooms. Again, like we did with the list, we're going to name it plural because we're going to be dealing with more than one room.
Right.
So that will take care of our private variable for rooms.
And again, this is going to look so confusing to those of you that are completely new to programming. Don't worry. Follow along. Let's get a functioning program going. We're going to break all of this stuff down in depth later on.
So with this being private, though, that means we can't access it from outside of level. And there will be cases when we need to look at the rooms grid and decide what room we're in, especially when we're the player and we've adjusted our position, and now we need to see what room we're currently in. So we will need public access to rooms, which means we're going to define a property now. And this will be a public. Now we want the exact same type, so we want of type room, and then we're going to say that it's two-dimensional, and name it similar just with the capital casing, rooms. Now, this is the block where in our other properties we had created a get and set for the property. In this case, I'm only going to place down a get, and what this will effectively do is make this property read-only. There is from the way we've designed the code, there's no reason that anything outside of level needs to change rooms.
Right.
It only needs to gain access to look at what's in a room. So we're only going to be able to return rooms.
Once our grid of rooms are laid out, we're not going to need to randomize up the rooms. But I'll tell you what, thinking from a logic point of view, if you had a set in there, whew, boy, you could really do some crazy stuff.
But without changing the engine, the most you could probably do at first is just break it, because if a room goes away while you're playing, that will cause a very serious problem when all of a sudden there's not a room.
Oh, I was thinking of like if we took a room out, stored it in a room, and then took another room and put that in that room, and then the stored room into the other room, so you're flopping rooms around.
Oh, wow, you're making portals in a non-visual game.
Exactly, very cool. Oh, guys, for those of you that are new, just ignore what I said.
All right, so back to reality for a minute. I was returning whatever.
Be quiet.
All right. So what do we want to access from the rooms property? Well, of course, the rooms variable. So we will return rooms if we are asked to get some room. And even though it's not as necessary here, I'm going to follow the standard I've started and place this within a region. So region, properties, and we'll end the region. And we'll spell end correctly, and there we go.
And we'll also go ahead and jump back up there and add static after public.
Oh, right, because the property itself has to be static along the same rules as the variable itself.
That's right, because it's a static class.
Good eye. That was about to be a fun error when we went to try to run this.
Now, I'd be pretty quick at telling you what was wrong.
It would. But with that, we can do the same thing as we did before and collapse it down. So we have our level, we know we have rooms within that level, and we've got a property to access it.
Fantastic.
So that takes care of level. Now, let's move on to item. What do we have inside of the item? Well, an item needs to have some text name, so like an apple would be called apple.
Right.
We need to have, it would be nice if we had some type of description whenever we pick an item up. Like let's say we pick up a note off the floor.
And it says, you have just picked up the note, and on the note you notice it says, don't forget to bring home milk tonight.
Right,
Pick up
again,
description.
Something that you wouldn't be able to see. Like let's say you're back in the real world. Something you wouldn't be able to see until you picked it up. Like a note on the floor, you wouldn't be able to read what's on the note until you went up to it and picked it up.
Right.
So we know we're going to have a title and a pickup text. Now, because we want items to have in order to limit how many items you can carry, we're going to limit by weight. That means on an item-by-item basis, we need to know how heavy that item is. So we're going to have a weight variable. So let's write these in. We're going to have our private string for a title. We're going to have a private string for our pickup text. And let me adjust the casing a little bit. And finally, we'll have a private integer to hold a weight. And because later on when we're designing a level, we don't want to have to set the weight for every single item, we're actually going to have this one default to a value of 1, so that unless otherwise specified, items have a weight of 1. So that takes care of the private variables. Now we need to define some...
So just even though it goes outside the scope, that's just that he's declaring and initializing. I'm just dropping a word. So it was like, imagine if you were just born, and as soon as you were born, your telephone number memory spot in your head has a telephone number in it. So you were born and initialized with a phone number. That kind of an analogy real quick.
But, all right, with these private variables now, we need to move on to their public property counterparts. So let's, matter of fact, before we even type out the properties, I could start a region. So a region for our properties. And if I'll spend a moment and spell that correctly. And region. All right, first property should go along with title. So we'll have a public string property with capital letter title. We'll block this in, jump into the block, define our get section where we return the internal title, and then our set section where we set the internal title to whatever value was passed to the title property, so equals value. And that rounds off our title property. Now, to avoid having to type out the entire block again, I'll select the entire thing, hit copy, hit paste again, and I could go so far as to hit paste a third time. So we have 3 property blocks, and then we can just rename these to their relevant variables. And then, of course, adjust the casing on the property itself. So that will take care of our pickup text, and we paste weight in a few times. We now have a property to access our weight variable.
Now you might need to go back and watch very slowly what he's doing, but he's falling into a pattern here. It's just the same thing over and over, the copying and the pasting bit.
And with those variables and properties, that wraps up item, or all the values we need inside. So I'm going to collapse down the properties block, and we can move on to the player.
Okay, now the player, what kind of things the player going to need to be aware of? It's going to need its position in X. It's going to need to know its position in Y. It's going to need another one of those really special kind of variables, a list, right? It needs to have all of the items it's carrying in that list. That's its inventory. And so it's going to need that. It's going to need to know a couple extra things that we're throwing in there. Moves. We're going to put moves in a player so that we can track. Each time we move north, south, east, or west, we can always increment moves. And that way, we can determine with game rules that if he's moved, 5,000 times, geez, is he ever going to finish the game? Let's just say he died because he's old. He died of old age. So moves will be a handy variable to have. And then, of course, we have another one that would be nice, a weight capacity. And just so we don't hard code somewhere, a weight capacity. This way, we have an easy place to go to and change the capacity if we wanted to in designing another game using this engine. So a couple things that we're going to throw in there.
Right. Or rather, put the weight capacity at somewhere where it's more obvious. Like you said, not bury it in some other routine.
You could bury it so that you could be so abstract as to not even put weight capacity. Later on, you could just in a pickup check.
If our weight is now 5.
Exactly. And so then it's not even denoted as a weight capacity, and then another programmer that came in behind you would have to read between the lines to pick up on that. So this just makes a lot of sense here. So let's go ahead and put these guys into play.
All right. Let's start with the private variables. We'll have a private static, because our player class is static, integer for position X, and a private static integer for position Y.
And if I may, ladies and gentlemen, look very carefully at the screen. Int position X, int position Y, and they are, in this case, private because we're going to make properties to get to them, but just as a reminder, if we come all the way back over here, and which one was I using? This guy. Actually, I think it was this guy right here. Yeah, look at that. Position X and Y. What did I tell you when I underlined these? That they were going to be integers. Now, right here we're showing public, but since we're going to make properties for them, they're private, and then we'll make with the capital P.
We're basically halfway there. We did something similar with the titles and descriptions of rooms, where they had a private area to store data, but then a publicly accessible property that did nothing more than access that. So it might as well have been public. It just gives us that extra layer where if in the future we decide we want to track accesses or prevent accesses, we could.
You got
it's just leaving that as an option for us to do later if we wanted. And it goes back to that whole security thing. It makes it easier to keep your data secure. Before we get into properties, we need to fill in the rest of the variables that a player will have. The next variable is our inventory list. So this will be a private static list. It will be a list of items, because items are what goes into the player's inventory, and it will be called inventory items. It could be called items, but inventory items gives us just a little bit more of a description as to exactly what it is.
Sure.
Not just items that have stuck to the user since he has walked through the level.
Right.
And after inventory items, we have our moves. So this will be a private static integer to hold number of moves. Now, even though it technically initializes to 0 anyway, we are going to set it ourselves, just to make absolutely sure that we start at 0, and specifying that as our starting point for moves. And finally, we're going to put in one last private static integer, and this will be our weight capacity. So weight capacity, and we're going to have that set to 6. So when the player is first added into the game, he has a weight capacity of 6. If we don't change it, it'll always stay 6.
And if everybody recalls, with all of our items, we defaulted the weight to 1 for each item. So if we don't go and explicitly tell any particular item what its weight is, its weight will already be 1. So we can pick up 6 default items, if you want to look at it that way.
Exactly. So that will take care of all of the data that we need to store. So let's begin our properties region. Region, properties. Wow, I'm doing awesome with the spelling of properties tonight. And in the region. Alright, so beginning with position X. As a matter of fact, to get one layer of lazier, I'm going to actually jump back to one of our existing classes, in this case item. Doesn't matter which one. I'm going to grab any property, copy it, jump back to player, paste it in. Matter of fact, I'm going to count out how many properties I need. Position X, position Y, moves, and weight capacity. We'll address inventory differently. So we've got that pasted in. We need another one for position X, another one for moves, another one for weight capacity.
And you meant position Y for anyone that was. I thought you just did one for X.
Oh, sorry. Alright, so beginning with position X. Let's copy its value, paste it in. But you've got to be careful, because I went and grabbed a property from somewhere else. That was a string property I grabbed. I need to change it to an integer to work properly when we go to get or set the value.
Right. And you need to change the casing.
Right. Otherwise this would cause a conflict. So position X throughout. Looks good. Now we can move on to position Y. Same thing. Paste the name in, change the casing, change the type, and that gives us our position Y property. Now inventory items. Inventory items isn't going to be stored as a public property. Instead, we're going to have it set up to where we can only get one item from the player at any given time, because that's usually all we'll need to check. You'll see that later when we get into the methods. So there is not going to be a public property for inventory items. There will, of course, be one for moves and weight capacity. As a matter of fact, let me just look at one thing real quick. Yeah, just following along, we'll do that. We'll let moves and weight capacity be public. So we'll have our moves, because of course we'll need to check this from somewhere to know whether or not we've run out of moves, like you would describe. We want to have that be one condition for possibly ending the game.
Right. And we'll go ahead and change this type.
Int, and then last property, weight capacity. And again, type should be integer.
Now we need to add one more property, and this is pretty interesting because you'll notice right now we've basically accessed all of our variables through properties, so we're adding another property, but it's not to access a variable directly.
Right. We do want to have one more thing available on player. We want to be able to ask the player what his current inventory weighs.
Right.
Because we have an inventory, we have items that have weight, so that would mean that if we added all those items together, they would have one total weight.
Exactly.
And we're going to put that together as a property because we want that weight to be accessible outside of the player. So we want a public property that will have, let's see, public static. I just realized there's something I have to change with these. A public static int inventory weight.
Yeah, don't think I was going to let you get far without throwing static in.
inventory weight. And this is going to be a read-only because, for one, it doesn't have a local variable, or it doesn't have a variable to store the data in.
Right.
So, I mean, setting it, there would be nowhere to put the data, technically. So, I'll start a get.
So all you can do is get information from it.
Now, what get is going to actually have to do, if we think about it, is it's going to have to look through our inventory, go item by item, and add up how much each item weighs, and store that as a total, and then return that through inventory weight. And we haven't gotten into the methods or functionality just yet. So in order to have this available and usable, but not have to write the functionality, I'm simply going to return 0. So it's, while it exists, it's not technically functional yet.
Right.
And it's just put in place as temporary to return. As a matter of fact,
want to add our first to-do?
As a matter of fact, we could. I'm going to change the get block a little bit, because we know that eventually we're going to have to do something more complicated, which will probably take multiple lines. So I'm going to adjust the blocking on this so that our opening and closing curly brace appear on different lines, and we have our return inside that.
Okay.
So here we could jot down a note. To do. Finish inventory weight calculation.
Now this is actually extremely handy what Logan is demonstrating right now. By putting in that / to do in all caps like that, we've set ourselves up to where if you come down to the bottom, you'll notice we have a task list. And if you click on the task list, look at that. To do, finish inventory weight calculation. Now this is really cool. Over on the right hand side you'll see what file it's in, what line number it's on, but even better if we go up to the top and we change to another class somewhere.
So let's go back to room.
So we're working in rooms, and then we need to go to our to-do list. We could walk through each one, double-click it, and it takes it back to the file, highlights that particular line, and we know where we can finish off this to-do. And when we're done with it, we can simply delete this line. Very, very handy when working on a lot of code, a really big program, and you've got pieces strewn all over the place that you are working on but are not yet finished and need further attention.
Right, of course, and it's very good programming practice to jot down notes about what needs to be done if something isn't finished yet. The current version of Visual Studio takes that another step and actually forms a list of everything left for you to do.
That's right.
So, alright, that I think should take care of player now. We've got all of our values, we've got our properties, and then, except for one thing.
Right, we're putting static in, yeah.
Right, that was about to...
I was going to get you to do that and then close it up.
Alright, so let's copy static a few times. Paste that in for each of our properties.
Yeah, once again, we're dealing with a static class, so all of these properties and variables must be static. So let's go ahead and collapse the region, and there we go, nice and clean.
So that will take care of player.
Okay, believe it or not, we're almost done, guys.
Alright, the next class.
Command processor doesn't have anything.
So we can skip right on past that and move on to our text buffer class.
Command processor just processes commands. Doesn't need to store any information.
Exactly.
It just needs to do stuff.
Basically just pass information along.
That's right.
Alright, let's go to our text buffer class.
Now, text buffer. It's pretty easy. Remember, this is a place that we're going to store text that we're going to end up sending out to the screen, and then we're going to display the text. And you can see the two commented methods that we've got in place, add and display. So let's think about it. What kind of a variable do we need? Well,
something dealing with text, and so far we've been using strings.
So we just need a simple string variable that we can dump text into.
And this is, of course, going to be a private variable since in order to interact with the buffer, you'll be adding or displaying. We don't want to be able to have anyone go and meddle with the information that's inside of the buffer.
No.
So this will be a private, and because this is a static class, static variable. It will be of type string, and it will be called output buffer.
And this is another really neat situation, because up till now, every time you've seen Logan do a private variable, you've seen him do a public property for it. But here's a case where we're not going to create a property, because we're not going to go through a property to add information into or pull information out of output string. Instead, we're going to have an add method, as you see commented there. Okay, and so we'll call on add and send information into add. Now add, it's kind of like that security guard that I showed you guys earlier. He's inside of the text buffer object, so he can turn around and take the information that you've sent into add and put it directly into the output buffer string variable.
And right, that's where we get our, like we were talking about, our level of security. So we know we can then rely on the information within text buffer because we know add was in charge of allowing things to go into it.
Exactly. And that leaves us with the oddball guy, our direction struct.
So let's bring up direction. And inside of direction, what types of variables? This will be another almost, as far as we've seen so far, special case. Let me type one of these out and then I'll review it. These will be public. So already we're getting off to a different start. Constant. String. Well, okay, string is familiar. North. And then, like we did in some of the other variables, immediately initializing it to some value. So north. Terminator. Wow. Okay, what have we just done?
We created a variable called north. That's its name. It holds alphanumeric characters. It holds text, a string. It is a constant. It is a constant value, and that constant value is north. It is not a variable where we go in and change the information in it. It has been burned in. It's almost like if we were to say you had a telephone number memory slot in your head, and we went in there with one of those, the old wood carving iron things, and we just...
Or even better, this is a barcode that has been tattooed onto your arm.
Okay,
now.
Barcode that's been tattooed. There you go. It doesn't change. It is constant. So north variable is equal to north. That's the text we're storing in north.
So, along with north, we need 3 other directions now. South, east, and west. So I'm going to grab the entire line, paste it 3 times, and now we can change each of these. So we have north,
south
is
east,
equal to
and
south,
apple. Just
east,
kidding. Let's go see if I can get him to type apple.
And west.
And apple. He paused for a second.
That'll work better when we get into items. Sure, that's an apple.
So there we go. That's the variables that aren't very variable that we have inside of the direction struct, and you'll see how creating these consts are going to be quite helpful later on when we start using direction. So with that pretty much wraps us up with what we wanted to get covered in this video, with the key thing being to introduce you guys to the concept of data needing to be stored somewhere, and then variables to hold data, and properties which allow us to interact with variables. Also, public and private, so we can start talking about some security issues with our objects, keeping some of their variables private to themselves and only allowing you to get into them through public properties. It doesn't mean that we can't take a variable and make it public, but again, generally not something you want to do. So again, I want you guys that are completely new to programming, relax as you go through this. I promise you right now, if you're new to this world, this is going to seem overwhelming. I understand that. Logan understands that. We will be breaking this stuff down. Right now we're walking you through making your first fully functional game just so you have the big picture. That's really important. And I'm going to continue to remind you of this. Breathe. It's good. It's all good. This will make a lot of sense by the time you get to the end of this course. So with that, that is going to wrap up this lesson. Thanks a lot.